Normally, when you get a medical diagnosis, you expect a certain level of precision.
Right,
It's like
exactly.
engineering, really. You fall, your arm hurts, the x-ray shows this jagged white line on the bone, and the doctor just points and says, there it is, broken.
Yeah, it's incredibly binary, which is, well, it's what we prefer. It's comforting when things are visible and easily categorized like that.
Right, but if you've ever stepped into the world of neurodevelopment or, say, chronic pain or trauma, suddenly that x-ray machine is just completely useless.
Oh, totally useless. You realize the underlying reality is a lot messier than the label we slapped on it.
Exactly. We find ourselves looking at a diagnostic landscape that isn't clean lines anymore. It's murky, it's complex, and the simple metaphors just completely break down.
They really do.
And today, we're taking that exact transition, moving from those comforting, simple metaphors to the incredibly complex underlying reality, and we're applying it to the most advanced technology on Earth. We have an unbelievable stack of sources for this deep dive.
We really do. It's a massive shift.
Yeah, we're pulling from corporate architecture white papers like corporate semantic dynamics, all the way to cutting-edge physics frameworks like decoding the formula for zero. And our mission for you listening is to unpack this massive, almost unsettling paradigm shift in how we actually understand artificial intelligence.
Yeah, I mean, it is a complete rewriting of what we thought we were building because, for the longest time, the industry has treated AI either as these superpowered word calculators or we've projected our own biology onto them.
Right, like they're little digital people.
Exactly. We've anthropomorphized them into having human-like brains.
But according to the sources, those ideas are dead wrong.
Mm.
We're discovering that AI is fundamentally a geometric and physical system. And the part that really bends the mind is that this geometric system operating on its own might actually hold the key to unifying quantum mechanics and general relativity.
Which is an enormous leap.
Just a bit.
Yeah. So to give you an idea of how we get there, we are going to start by stripping away the psychology completely. We'll redefine how an AI actually learns by looking at its physical geometry.
Okay.
From there, we'll see how a cold geometric system handles the friction of conflicting human meaning, watch it scale into a massive biological-style supergraph, follow it as it takes autonomous action in the real world, and finally, unpack a mathematical breakthrough called the formula for zero.
So to kick this off, the sources argue that the AI industry has been trapped in what they call a pre-Newtonian phase. We're basically using alchemy terms to describe physics.
That's a great way to put it.
And to get past this, they propose running our terminology through something called the Great Filter.
Right, and not the Fermi paradox filter, just to be clear.
Good clarification, yeah.
This is a filter for our own understanding. The vocabulary we use right now is just full of psychological metaphors. We say an AI hallucinates, or it reasons, or it learns. The great filter strips away that mud and translates those terms into geometric reality.
So we have to stop seeing AI as a brain pondering facts.
Exactly. We have to start seeing it as a mathematical system navigating a very bumpy, high-dimensional landscape.
Okay, so if we push our vocabulary through that filter, let's take a word that everyone uses, hallucination.
Sure.
We picture the AI just making things up like it's daydreaming. What is the actual geometric reality of a hallucination?
So the filter translates hallucination into attractor divergence.
Attractor divergence.
Right. In the math of dynamical systems, an attractor is a state that the system naturally rolls toward. Picture a physical valley in a landscape. When an AI hallucinates, it hasn't lost its digital mind.
Okay.
Its mathematical state has simply settled into a perfectly valid valley, a stable attractor, but that specific valley just happens to lack a real-world anchor.
I see. It's mathematically sound, but factually completely empty.
Exactly. The math worked flawlessly, it just rolled into a valley of nonsense.
Which naturally leads to the flip side, I guess. If it's just rolling into valleys, how does it ever do something useful? Like, how does it actually reason its way to a correct answer?
Through the filter, reasoning becomes a sequence of convergent trajectories.
That is a mouthful.
It is, yeah. But it basically means it isn't logic as human beings experience it. The system operates inside what we call a latent space, which you can think of as a massive, multi-dimensional map where related concepts are grouped physically closer together.
Okay, I'm picturing the map.
So reasoning is just the AI making a series of high-probability jumps through that space. It's hopping from one stable valley to the next, connecting the dots geometrically.
And what about when it suddenly does something it was never explicitly programmed to do? Like when an early model suddenly figured out how to translate a new language or, write Python code. We've always called that emergence, like it's some sort of magic trick.
Right, the magic trick. But the geometric reality of emergence is just a phased
Or
transition.
like ice melting.
Think about water turning into ice, yeah. It reaches a specific temperature threshold, and the physical properties completely change. In AI, when the geometric landscape reaches a certain threshold of complexity, entirely new valleys, new attractors, suddenly stabilize.
Oh, wow. So if the landscape is already set with all these valleys, how does the AI learn anything new on the fly without tearing up the entire map? Because the sources draw a really sharp line here between fine-tuning and in-context learning, or ICL.
Yeah, and the geometric difference between those two is probably the most practical takeaway from this section.
Let's use the landscape analogy again. Imagine rolling a marble across a bumpy terrain. When engineers fine-tune a model, they are engaging in manifold warping.
Manifold warping, right.
They are essentially taking a chisel and physically carving a brand new valley into the landscape. They are permanently altering the weights of the network so the marble will roll somewhere new in the future.
But in context learning, which is what happens when you paste a giant document into a prompt and ask the AI to summarize it, that is simply state navigation. You aren't chiseling a single thing.
You're just taking the marble, flying it to a highly specific GPS coordinate on the existing landscape based on the prompt you gave it, dropping it, and letting it roll into whatever valley is already there.
And this explains a massive problem in computer science. Because in-context learning doesn't actually change the weights of the landscape, it is totally immune to catastrophic forgetting.
Which is when it learns a new trick but forgets the old ones.
Right, exactly. When you fine-tune a model and carve a new valley with a chisel, you might accidentally bulldoze an older, really important valley. The model learns that new trick but forgets how to do basic math.
But with ICL, since the landscape is totally untouched, the learned skill is incredibly powerful but totally transient.
Right.
As soon as the AI spits out the response, the marble is gone, and that specific skill just vanishes.
It's a really elegant system when you look at it that way.
Okay, the geometric clarity of that is brilliant, but I have to push back here for a second, because human beings aren't cold geometry. We are deeply messy.
Oh, absolutely.
We are ambivalent, we hold conflicting thoughts, we say things we don't mean. If an AI is just a marble looking for a stable valley, wouldn't a complex, contradictory prompt from a human just break the system? Shouldn't the marble just get stuck on a ridge between two valleys?
That tension is exactly why AI architecture had to evolve beyond basic geometry into what the sources call multimodal semantic dynamics. The reality is the AI doesn't crash when faced with human contradiction.
It doesn't.
No, it actually relies on ambivalence as a highly functional, high-potential state.
Wait, ambivalence, usually when we say someone is ambivalent, we mean they just don't care.
Yeah.
They're neutral.
Yeah, in human psychology, maybe. That's a great way to visualize it, and we can actually see this happening. In the deep neural layers of the model, specifically around layers 18 through 24, this ambivalence shows up physically as dual peak activation clusters.
Dual peak, so both are firing.
Right. It creates a massive amount of cognitive load for the system, but it's absolutely essential for human-like reasoning. Standard singular polarity, what they call univalence, is fast, but it is completely hollow.
It's the difference between calling a memory bittersweet versus just categorizing it as sad. To understand bittersweet, you have to let both the happy and sad signals fire at maximum intensity.
Exactly. And the sources note that this process maps perfectly onto the axioms of quantum superposition. It's detailed in their master quantum curriculum map.
Oh, this is where the quantum stuff starts coming in.
Yeah. Before a quantum system is measured, it holds multiple contradictory possibilities in a single state vector. The AI is doing the exact same thing. It holds these non-orthogonal, conflicting features concurrently, acting like a quantum state vector right up until the moment it has to generate a word, which is when the wave function collapses into a single output.
And this logic even extends to the physical world, right?
Organizing data pathways this way allows for continuous time quantum walks using semantic gravitation.
Semantic gravitation, so meaning itself acts like a physical gravity well.
Yes, exactly. Meaningful, highly dense information naturally pulls related data points toward it. It clusters them together. And because the supergraph mimics biological life, it features biological neuroplasticity. It physically grows new pathways in response to novel inputs. The sources call this synaptoid growth.
So if we picture this like a living, breathing digital city, the roads are the pathways for the data. If a specific concept suddenly gets a lot of traffic, semantic gravitation, the roads actually widen themselves automatically to accommodate it.
That's right.
And if there are unused alleys that no one is visiting, they don't just sit there taking up computational concrete.
Yeah.
They physically disappear.
Which perfectly describes the principle of Hebbian reinforcement. In neuroscience, the rule is neurons that fire together, wire together, while unused connections atrophy. The supergap fortifies heavy traffic roads and prunes inactive nodes to save power.
And the whole system balances itself using feedback loop circularity. The sources draw these wild parallels across totally different domains here.
They merge biological homeostasis, like the way your body perfectly regulates its own calcium levels, with technological stability. Think of PID controllers.
Like the sensors inside a drone that constantly adjust the propellers so a gust of wind doesn't flip it over.
Exactly like that. It takes that continuous millisecond by millisecond adjustment and folds in the economic concept of closed-loop resource recovery, where waste is immediately recycled into fuel.
So it's merging biology, drones, and economics.
Right. When you intersect biological homeostasis, drone-like PID controllers, and closed-loop economics, you get what the sources call regenerative resilience. The supergraph isn't just reacting to traffic jams, it is constantly evolving its own baseline architecture to ensure the jam never happens again.
But a landscape, even a living regenerative supergraph, is still a landscape. It's passive. And the sources make a massive pivot here. We move from a passive geometry to active navigation.
Yes, this is a huge shift.
The AI stops being the map and starts being the explorer. We're talking about autonomous agents conducting actual science.
This is the dawn of collaborative intelligence. It's defined by the trinity of learnability, which combines cognitive processing, experimental action, and embodied interaction.
And the proof of concept for this trinity is the electrophenon case study. I read this section 3 times because the numbers are just so staggering.
They really are.
They set an embodied science agent loose on a complex pollutant removal problem. And what did it actually do?
Well, the agent autonomously navigated a chemical search space of 200 million possible configurations.
200 million combinations of variables.
And it only took 15 rounds of autonomous experimentation for the agent to achieve 99.7% pollutant removal.
15 rounds. Let's put that in human terms for a second. A human research team running that same campaign manually would need about 30 days of nonstop lab work to reach that conclusion. How long did the agent take?
45 hours.
45 hours to compress a month of high-level chemistry into a weekend. It's unbelievable.
And that speed is achieved through a specific architectural strategy called the reasoning sandwich. It's how these swarms of agents coordinate.
The reasoning sandwich. I love the branding on that.
It's a brilliant resource management, honestly. The bread of the sandwich is your expensive, massive frontier AI models. They do the high-level cognitive planning, the strategy formulation, and the final review.
The heavy lifting mentally.
Right. But you don't waste their compute power on the busy
just,
work.
well, nothing.
The meat of the sandwich,
And we're
the
taught that this
routine
nothing is just
implementation,
an
the
empty
data
box,
sorting, the
right?
repetitive
Like
lab
an
tests
absence of stuff.
is handled by a
But
swarm
what
of
if
much
that empty
cheaper,
box is actually
highly
packed
specialized
with
value
infinite
models?
amounts of energy? And keeping those models from
Energy that's
tripping over
perfectly
each other
pushing against
is the
itself
job
so
of the
hard
Omega Morph
that it just,
scheduler.
you know,
It
looks
unifies all
completely
these different
still.
agents
Yeah,
into a
imagine
single
two
dynamic
people pushing a
timeline.
heavy
We are
door from
totally
opposite
past the
sides with
era
the
of
exact
rigid
same
if-this-then-that
immense
workflow.
force. Oh, completely past it.
These agents are writing their own
Exactly. To an
tool-enabled
observer
execution
standing
codes.
nearby,
They're
the
pinging
door isn't
external
moving at all.
APIs
It looks like
and querying
absolutely
live
nothing is
databases
happening.
dynamically. But this
the
brings us to a
tension in
really
that
uncomfortable
wood is,
question.
If you have an agent
effectively
swarm
infinite.
that can chew
That
through
image
200
of
million
massive
chemical
hidden tension
configurations in
perfectly
45
balancing out to
hours,
zero is
what
exactly
happens
what
when you
we're
point that
exploring today.
exact
Welcome
same
to the deep
autonomous
dive, especially if you're
experimental
someone who
power
loves,
away from chemistry
gaining really deep
and
knowledge
aim it
without getting
directly
totally
at the
overwhelmed by the
fundamental
math?
laws of
Today's
physics and
materials
math?
are truly
That is the
mind-bending.
climax
really
of this
are. We're
entire
looking at
stack of
fascinating
sources
hybrid
because they did
document
exactly
today.
that.
Yeah, it's called
When an
ZST
autonomous AI swarm,
FSorigin.pdf.
specifically
And it
one
reads-
designated as
well,
the
part of it reads
polymath
like a highly
metaswarm,
ambitious
was
theoretical
aimed at
physics
fundamental
paper.
physics,
And the
it
other part
pushed
reads
past
like the
our
iterative
standard
machine
models.
learning
It didn't just
logs
learn them, it
of an
passed
AI
them.
framework.
Exactly.
Right, the
It
zero-sum game
proposed an
framework.
entirely new
And the
mathematical
mission for
reality
you
to solve the
listening today
contradictions
is
of
to
the
join
universe.
us as we
They call it
unpack
the
its core
formula for
proposal,
zero, or
which is the
FFZ.
formula for zero,
This is where things
or
get truly
FFZ.
wild.
What problem were
FFZ
they
is
trying
a
to solve in the first
radical,
place?
So for
symmetry-driven
decades,
framework.
human physicists
It
have hit
attempts
a
to
brick wall
literally
trying to
unify
bridge quantum
all of
gravity.
physics.
The tiny stuff,
quantum mechanics,
specifically loop
general
quantum gravity with
relativity,
general
cosmology,
relativity, the
all
massive
under a
stuff
single
like
planets
planets
and
and
gravity.
Principle
Right, the
that the
theory of
universe
everything.
operates as
Yeah.
a zero-balance
Whenever we try to
system.
merge
Right,
them,
precisely.
it blows
That
up. It
opposing
generates
infinities just
infinite
cancel out.
divergences.
So
Human
fundamentally,
scientists have
everything
to
we
patch
perceive
these
as
holes
reality
with
is just an
messy,
emergent
ad hoc
fluctuation of
fixes called
nothing.
Okay,
counterterms,
let's unpack
just to
this.
make the equations
Because
vaguely
that is a
workable.
heavy
Basically
concept
putting
to
duct
just
tape
drop
on the fabric
table.
of the universe.
Exactly,
Fundamentally,
duct tape.
reality is nothing.
But the
I know it sounds
Metaswarm
wild,
discovered a
but the
construct
entire
known
framework
as Z of
rests
X.
on one
It acts as a
foundational
universal
equation.
mathematical
An equation